Welcome to Study Loop.
In problem 9, we're going to be looking at data on hunting accidents in two different areas. A game commissioner is using this data to tell whether the number of hunting accidents in counties in the west is different from the number of hunting accidents in counties in the east. And we're going to be using the 0.05 level of significance to see whether there's a difference between the number of hunting accidents in these two areas. So the null hypothesis will be that there is no difference in the number of accidents in the two areas. And the alternative hypothesis is that there is a difference in the number of accidents in the two areas. Next, we're going to get the critical value of Z, and since the level of significance is 0.05, the critical value of Z is plus or minus 1.96. Next, we have to look at the rankings for the two areas, and the table here shows the different rankings for the eastern part and the western part. Now, the N1 should be the sample for the sample size for the smaller sample, and in this case, we have both regions having the same sample size. Therefore, either the eastern or the western could be used for N1 and N2. In our case, we're going to be using eastern part, which is 10. And for N2, we're going to be using 10, which is the western part. Now, R is the sum of ranks for the eastern part, and that is given by adding all these values of rank from 1 to 16. And the value of R is 71. Next, we get mu R by substituting the values N1 and N2 into the equation, and mu R is 105. After that, we work out the value of sigma R by substituting the values of N1 and N2 into the formula, and then solving. So this will give us 13.23. Finally, we can work out the value of Z by substituting the values R 71 minus mu R 105 divided by sigma R, which is 13.23, and the result is negative 2.5702. Next, we compare the values of R, the critical value, and the calculated value of R, and we can quickly sketch the critical regions at the 0.01 level of significance. So in our case, we see that it's negative 1.96 and positive 1.96. So you can shade on both sides to show the critical regions. So the value of the calculated Z is negative 2.5, which is to the left of negative 1.25. So in this case, we find that the calculated value of Z is within the critical region, and for that reason, we are going to make the decision to reject the null hypothesis H0. And rejecting the null hypothesis H0 leads us to make the conclusion that there is enough evidence to support the claim that there is a difference in the number of accidents in the two areas. We also say that the number of accidents may be related to the number of hunters in the areas.